Okay, we're going to do another very short squat cylinder, much like the coin we did earlier. But this one is a washer, kind of washer that you might use if you were assembling something using nuts and bolts. All right? You got the nuts and the bolt, and then the washers are on there to help hold it. Anyway, the only difference now with this calculation is that we have to somehow subtract away the inner portion of this metal cylinder that's missing. All right. So let me draw this picture. And let's first measure the thickness right here. And that, of course, would be the height of this very squat, very short cylinder. All right. And that reads 2.57 millimeters, which of course we're going to change over to centimeters. It's just the measurement, the unit of measurement we want when we do volume calculations. So it'll be 0.257 centimeters. To get from millimeters to centimeters, you move over one. All right. Anyway, what we are going to do now is draw these little dotted lines here. We want to know the distance across the entire washer. That'll be the diameter of the washer. All right. And in this particular situation, we've got a diameter of 25.62 millimeters, which is 2.562 centimeters. All right, that's this distance right here across the whole washer. Right. I'm going to put D and then a little W underneath it for the washer, diameter of the washer. All right, that'll be that one. Now, what we also want to do is measure the diameter of the hole. So, go ahead and I'll put that as a different color here. But to measure that diameter, I'm not going to put it in this set of jaws. I'm going to use this set of jaws up here. Right? IDs are inside diameters. You use these set of jaws up at the top here. So let me see if it's reading 0. Yeah. In there. 11.21 millimeters, which is 1.121 centimeters. I'll put a little green dotted lines right here. And I'll call this the diameter of the hole, D sub H, is this distance right here, from here to here. And I'll just write it right here, 1.121 centimeters. All right. Yeah, it's a little messy. Diameter of the hole is from here to here. Diameter of the hole is 1.121 centimeters. Now, just to give you a general idea of what we need to do here, we want to know the volume of just the metal. All right. What volume of metal is contained in this washer? Now, if we took the volume of this whole thing, assuming there was no hole, we would say that the volume of the metal would be the volume of the washer minus volume of the hole. Volume of the washer minus the volume of the hole. And I think I'm going to leave it there for you guys to figure it out on your own. Now, of course, the hole also is a cylinder. So get the volume of the washer as if there were no hole in it, and then get just the volume of the hole. Right? Both of these are using the same formula, pi r squared h. Right? Pi r squared h, but this r is the radius of the whole washer. Now we know the diameter of the whole washer, cut it in half and stick it in there as the radius of the washer. Right? R sub w squared times h. H is the thickness of the washer. Minus pi r squared h for the hole. Right. The radius of the hole I didn't measure. I measured the diameter of the hole, so I just need to take the diameter of the hole and cut it in half. So it's going to be the radius of the hole squared times h. So the volume of the metal would be that right there. Pi times the radius of the whole washer squared times the height. Notice the h here for the washer is the same as the h for the hole, so these h's are the same. The only difference is the radii that we're putting in here. This is the radius of the washer, right? The big piece, and then this is the radius of the hole, the small bit in the middle.